As a next speaker, I would like to invite Yatin Préchon to the stage. Yatin is Managing Director, Global Advisory for Black & Veatch in Asia and the Pacific. As a strategic specialist, he guides private and public sector infrastructure investment and the development and implementation of decarbonization pathways, strategies, technologies, and projects. As Black & Veatch, Yatin has been involved, at Black & Veatch, Yatin has been involved in the commercialization of several major gas-to-power projects across the region, more than 40 gigawatt of sustainable energy and conventional power development. The formation of technical and financial mechanisms to repurpose coal plants and regulatory advice to developers and large industrial companies on the development of green and blue hydrogen projects and emerging decarbonization strategies. So Yatin, over to you, please.
Thank you. Thank you for that introduction. Good morning, ladies and gentlemen. Peter, you've taken my presentation, man. He's covered a lot of the stuff I was going to cover, which is great, at least setting the scene and the context. As a company that works on the EPC front, we do see a lot of, I wouldn't say issues, but challenges with respect to the clients that we work with, and especially in the data centers space where we build data centers across the planet. There's a paper that we'll be launching around this as well in terms of the balance between carbon intensity, utilization, and the use of AI. So that should be out in the next month or so. So keep an eye on that. Follow my LinkedIn profile. This is my plug. So yeah, with that, is it going to work? Oh, it's going to work. Great. With that, as Peter mentioned, right, there is, well, Asia is responsible, or APAC's responsible for pretty close to now 50% of emissions. From a lot of that from industry and transport, a lot of that from burning fuels. We're looking at something like 53% of these emissions coming from heat and electricity usage, and about 12% from transport. However, the contribution globally is somewhere close to like 25% as well. On the AI front, what we're seeing is about a 15% cigar in that industry itself. So that's a huge growth that we're going to see in the next 5-6 years with respect to data center development. These are not piddly data centers. These are 2 to 4 gigawatt facilities that are going to be plugged in cities, right, or near cities. The amount of power that these data centers are going to require is going to be immense. And what we're seeing as a challenge in managing ESG commitments, for example, from the likes of Google's and Facebook's and everybody else, including the service providers that use the data centers, is now a concern around, if we are going to look at the sustainability targets of the data community, but also look at the sustainability targets of countries and power producers, where is that nexus in terms of being able to effectively implement renewables and or sustainable fuels to power this infrastructure that's going to power our economy? And that's a bit of a gap, because currently, even in the Americas, this debate is now moving into, well, should we just use coal and gas? Which kind of is counterproductive to where we're going, right? So the use of AI itself, blockchain, AI, and everything else that Peter just mentioned, the escalation in the amount of energy we need to power that next generation of industry development and economic development to get to that next platform of evolution is going to drain and have a huge fight with our ESG targets. And that's especially true for renewables, and or should I say especially true for countries that are in the developing cycle currently. I mean, if Europe and the US are having these challenges, you can imagine what Philippines and India and Indonesia and Africa and South America are going to be facing. So it's a big growing challenge. The question is, how do we effectively use the capabilities of AI to actually influence and optimize and improve the carbon intensity, right, of using those systems and power. But at the same time, it's also looking at how do we look at energy efficiency. So there'll be, I think, some discussions around energy efficiency in a few minutes. And yes, that is the lowest hanging fruit, but it's not going to play a role in these kinds of massive mega data centers, right? It's not even hyperscale, it's beyond hyperscale. So with that, what do we look at, right? We've got to look at energy efficiency, as I mentioned just now, but trying and targeting more like a systems view, looking at using digital twins, for example, right, to be able to analyze how much energy these data centers and the technologies that are feeding into the data centers use, right? That includes electric vehicles, that includes sensors, that includes drives, and goes on and on the list, obviously, the whole of industry, right? It's also looking at how do we close the gap between demand and supply, right? Generation and use. And that's, again, an area where data centers and AI plays a role. How do we optimize the on-time delivery and generation for use, right, across all of the different forms of electrons and fuels? And obviously gradually moving into more sustainable fuels and electrons. How do we look at storage as a play? Now, what storage doesn't mean BESS, right? It could be pump storage. It could be hydrogen, ammonia, alternative fuels that are able to time shift across seasons. It's looking at not only chemical, but it's also looking at physical storage, right? So it's flywheels and flow, etc. How do we use all of those different technology packages, and where do we apply them to be able to gain that optimization of, or should I say, to be able to reduce the intensity that we'll have as a result of the amount of data we're going to start crunching, right? So just to come back, right? It's data-driven decision making. It's looking at optional analysis and actually configuration of that. So again, AI will help us, but then we also have to be quite practical about where those impacts are on the environmental side. It's a very complex machine, what we're going into, right? It's no longer, and we cannot afford to look at this play with respect to data in a compartmentalized way. So we have to look at it in a systems approach, in a solutions approach, across the whole of economy. Manufacturing, transport, agri-tech, behind the meter, domestic, residential, C&I, and if we miss out any of these, some of these components might end up totally contradicting our climate goals, right? So it has to figure all of this integrated into a solution system, which basically works like our body, right? So we have to look at it in an organic fashion with respect to the interdependencies, the relationships, and kind of fuse all of this into one solution. And that's going to take a lot of power and a lot of energy to break out of the conventional model. Give you an example. This is a cement group that we work for. And if you were here on Monday, I would have talked more about what we've done on the EV side for this company. But the reason I put this up here is not because of a hard to abate industry of cement. It's about the electric vehicles and the amount of data they consume in terms of planning, the amount of energy they consume, in terms of optimization of routing, right? And how do you then use the smarts behind a charge point infrastructure project to be able to enable that for this complex delivery of power, right, and energy. So there are interdependencies again, and that's kind of why I put this up here as a critical enabler. We have to start looking at EV infrastructure as virtual storage, as a mechanism to use electrons across a grid to be able to power systems, to be able to time shift, right? And that's something as a business model this client of ours has been suggested. We've suggested that to them. Unfortunately, the market isn't ready the energy market isn't ready in the country. but it is in some others. So Philippines is a great case study for something like this, V2G. Malaysia is moving into this kind of a scenario as well. Singapore is moving into this kind of a scenario as well. And if you look at those plays, we need the interconnected grids at some point to also communicate, right? So it's way beyond just the siloed approach of industry and using specific technologies. This is an example of a project we delivered in Thailand for a power producer. Again, it was looking at several layers of integration underpinned by data, right? So it's a smart city. It's a service that our client brought to the table to build smart cities as a service, as a utility. So you've got water, waste, power, digital infrastructure, transport infrastructure, heating, cooling, and there's a whole list of stacks with respect to layers, right? And all of that's connected through a human interface that manages the people connecting to the technology and optimizing that whole ecosystem of solutions. So stuff like this is already happening. It's how do we then integrate, say, for example, a smart city or a smart town or a smart campus into a bigger smart system, so that then becomes a tool for so let's just say it becomes a microgrid tool for a larger system of microgrids that becomes the grid, right? But that takes data. You need to have a lot of connectivity between the different types of microgrids, if you will, and things. So it's very complex, but it's a critical aspect of where we need to think a solutions thinking approach rather than looking at specific components of the challenge. Lastly, this is our office, our headquarters in Kansas City. So we have a data center there as well, and we have a lot of interesting toys that we play with in our own campus. But again, all of this is managed through now an AI-driven solution for our own campus as a demonstration showcase of how this could be done globally. So what we're trying to do is actually have a platform. We don't own technology. We're an EPC, we're an independent, we're an advisory firm as well, but we don't own the tech, right? We buy tech, we integrate tech, and we integrate solutions. So what we've tried to do here is actually have a showcase for clients to come and see that's operating under our own roof, just to show the demonstration of how this thing works, right? So I'll share all these slides, but again, the context, what we're trying to communicate is that it's not as simple as just looking at data or a specific technology. We have to look beyond that into a solutions approach, including finance, including regulation, and including solutions that can work together. I'll skip this slide, but there's more about what we do. And thank you. Hope that was enlightening-ish.
Thank you very much, Yatin. I think it was exciting, not just enlightening. Now we have another very knowledgeable and expert, Dr. Pei Sung Chua. Pei Sung, this is too loud. Pei Sung brings over 14 years of extensive experience in the energy and chemical sectors within Europe and Asia and the Pacific. His expertise lies in optimizing energy usage within utility systems and integrating heat within intricate refinery and chemical environments. With a track record of conducting energy efficiency workshops for refinery and chemical plants across Europe and Asia and the Pacific, Pei Sung has demonstrated impactful leadership in the energy as an energy manager. And notably, he spearheaded the successful implementation of an in-house energy management system, resulting in remarkable energy efficiency improvements of over 10% within a span of 3 years. Currently serving in the as a business development manager at Schneider Electric, he holds responsibility for chemicals, for the chemical segment. So Pei Sung, over to you, please. Yes.
Good morning, ladies and gentlemen. First of all, I'd like to thank the organizer for inviting us to share with you some of the advanced solutions that we have deployed to help some of our customers. I'm only given 8 minutes, as such, I will carry on. Just 2 slides to briefly give you an idea what Schneider's is. We pride ourselves as an impact company using these 5 guiding principles to manage our business. We are leading ESG by example in our own ecosystems. Our mission is to be our trusted partners for sustainability and efficiency. We organize our solutions using our EcoStruxure architecture, and they are organized in 3 layers. This is a typical examples for our solutions for the petchem industry. And of course, we have different structure and for the data center, but they're all organized in this architecture. The connected products are what's installed on sites. The edge controls are what's controlling in your plants. And more importantly, the apps and analytical and the service layer, that's where our advanced digital solution reside. So a quick recap of the structure. We have the connected products, the edge control where IT, OT converge. Our AI's offer sits in the apps and analytic layers. We have readily made digital solutions that's already in place, such as predictive analytics and real-time optimizations. But what's unique about us, we have a dedicated AI teams that provide AI consulting to help clients address specific challenges with custom-made AI solutions. Once we have successfully deployed them, we can replicate them. We'll move them over to a standard offer. Since we are talking about AI, just want to bring everybody in the standard understanding of what do we mean by AI. AIs can go from traditional programming, rule-based, all the way to the deep learning, be it supervised, unsupervised, or state-of-the-art deep reinforcement learning. Next, I'm going to share with you some use cases that are leveraging existing digital solutions. With sustainability on the forefront, one of the ironic challenges for the industry is to minimize carbon emissions from their operations. And from our perspective, we need to do this right from the start. And this start is not at the manufacturing plants. I will share more later on how a digital and equipment digital twins can help them operate the plant as efficient as possible. But we need to start further upstream, starting from planning. Which crude to buy, which product to sell? How can this impact the entire carbon footprint? Is there other crudes that can make the same amount of product at a lower carbon footprint? If so, what are the impact? What are the challenges? For long-term, mid-term investment planning, we need to consider alternate feedstock, alternate fuel. We have the digital tool to be able to evaluate the carbon impact from these choices. So once you have the right plans, the site then needs to execute this as efficiently as possible. We can achieve these efficient operations with our process digital twins. By combining advanced process control and a process digital twins, we are able to perform real-time optimizations. We ensure that the plant is always operating at the most efficient point 24/7. With a predictive emission model, we are able to predict and monitor our environmental impact. And finally, with all the latest site constraint and operating parameters, these are fed back into our planning tools and model to have the most accurate planning and scheduling tool. Once we are operating our assets as efficient as possible, we need to make sure that our equipment are reliable and operating efficiently. This can be achieved with what we call an equipment digital twins. Traditional way of equipment health monitoring typically look like this. Anyone who does equipment monitoring would know it. But with predictive analytics, we are able to collect all the information, put it in our custom AI model, and simplify to something like this. This enables us to be able to easily and quickly identify potential failure and address them before something catastrophic happens. These are some of the clients who have deployed some of our solutions to improve their reliability, improve their bottom line, and reduce their CO2 footprints. Not much time. Next is the more interesting part, how we are leveraging advanced digital solutions to help some of our clients. So this is our typical workflow with our customer when we want to deploy a custom AI use case. We work with them all the way from initiation, pilots, and actually scaling out and rolling out the use cases. We have a client who operate a large RO water plant. They need to minimize their OPEX, do predictive maintenance on their RO. So what we did is we took all their available operating data for the past 2 years. We built a machine learning model to represent the system energy consumptions. The client is currently doing 4 cleaning in place every year per skids on a time basis. So instead of using a time basis, what we try to come up with is, can we optimize the cleaning schedule? Instead of time, can we use condition-based? We run the model. What we found out that by optimizing this 4 cleaning schedule a year, we are able to achieve between 1 to 3% specific energy consumptions per skid. The next question is, can we improve the run length of the membranes? Because currently it's a time-based change-out due to unrecoverable foulings. So what we did is we built in a second model to forecast the health of the RO that uses a time series forecasting to determine when to change out the membrane. So with this, the result is that we are able to extend some of the RO time spans by between 6 to 12 months. Oh, I have 50 seconds, it's counting. I think the most interesting part is deep reinforcement learning, right? In a live chemical plant, we cannot do deep reinforcement learning like how we are doing with self-driving, right? So what we do is we leverage our dynamic digital twins. We couple it with third-party AI agents to perform this reinforcement machine learning. We provide the AI agents with the scenario, the carrot and stick. We set the boundary and let it find its optimum point for the objective functions. We believe we can leverage this mode of operations to optimize the standard operating procedure. When should we do something? To put in an online advisor to our operators and ultimately autonomous operations. Recently, we have a client who came to us. We are working on them on this particular case. It is a MA plant, a chemical plant. What they want to do is they want to be able to automatically switch reboiler from a startup reboiler to normal operations, from steam to hot water. Right. So what we did is we used that approach. We use an AI agent coupled with our dynamic simulations. We put in the column parameters. We put in the requirement, what they need to do, the changing, the tuning, and the result shows us that we can save the switchover time from 2 hours to 30 minutes. So what's happening now with the clients, my team is working with them to connect the data to the real plants and then do an AI visualization on it for the operators. In conclusions, digital solutions, we need to do end-to-end carbon chain planning. This is essential to sustainable operations. Kickstart your decarbonization journey by adopting well-established digital solution first that's already in the market. Be selective when choosing use cases for advanced digital solutions. That's all I have. Can take the question later on. Thank you.
Thank you very much, Pei Song. I think very interesting examples from some important hard-to-abate sectors. Next, I would like to invite April Herrera. April heads the ABB Motion business in the Philippines, a role she has held since 2023. April has been with ABB for some time, since 2018. She started as an account manager, where she was responsible for managing channels related to infrastructure, OEMs, and HV DC as well as AC systems before progressing to the position as Channel Business Manager in 2019. With a Bachelor of Science degree in the electrical engineering from the University of Santo Tomas, April brings over a decade of remarkable experience in the electrical industry to her current role. So April, over to you, please.
Thank you, Annika. Good morning, ladies and gentlemen. I'll just be quick about my presentation. So, ABB has been all over the world. In total, we have around 107,000 employees. And also, we are present around more than 100 countries all over the world. So, just a quick background, ABB is a technology leader in both electrification and automation, enabling a more sustainable and resource-efficient future. So this is just a background of how we are doing in terms of revenue in all over the globe. So here, just to give you a quick background. So we all know that there are many changes that we can make in terms of reducing the CO2 or CO2. So as you can see in this, the improvement of energy efficiency plays a big role in terms of the reduction of CO2 and co-equally with the change in renewables. So as you can see, these are a little incremental in terms of fuel switch, CCUS, and others. And in improving energy efficiency is viable solution to meet the climate change goals that we are aiming all over the world, not only in the Philippines. So as Annika mentioned, I'm heading ABB Motion business. ABB Motion business caters both motors and drives and generator products. So just to give a quick background, there is 300 plus millions motor-driven systems, not only in like different sectors like oil and gas, power, water segment, and the number is predicted to double by 2040. As you know, everything is improving and everything is engaging. So as you can see, 70% of the electricity is being consumed by industry by the use of electric motor-driven system, and many of it run inefficient, and it is impacting both profits and environment. Why inefficient? Because most of the motors are running only in IE1 efficiency, wherein some of the the first world country are now doing IE5 efficiency motors. So by means of optimizing and upgrading high efficiency systems, we are seeing to cut global consumption by at least 10%. And for ABB motors, we have this IE5 synchronous reluctance motors. They are permanent magnet motors, which offer up to 40% of energy saving, or equivalent to lowering energy cost. And on the large motors, ABB just recently launched the TIE, or what we call the Top Industrial Efficiency Initiative, to always ensure that we offer the highest efficiency. And of course, if there's motors, there's always drives. So why adding drives matters? Just under 25% of the world's industrial motors are equipped with drive, but most of it are, direct online system, or what we call DOL, and mechanical brake valve and applied system. So we can see that around 50% of the industrial motors would benefit if it is being paired by BFD or variable frequency drives. Maybe some of it you have experience are connected with soft starters, but we are aiming to achieve looking forward of pairing all of the efficient motors to drives. So looking at it, when added to an existing motor of pump, fan, or maybe a compressor, a variable frequency drive can typically reduce or help reduce power consumption by 25%. So the drives allow better startups and lifetime optimization and motor-driven systems. So I think most of us know that motor usually life cycle is usually up to 25 years. So the drives can help it to be optimized. So in addition to drives and motors, of course, there is an importance of datas. So about 85% of the companies say that they are now adopting to IoT initiatives. And they say that $7 trillion dollars are being spent on digital transformation between the year 2020 to 2023. And companies need data-driven decision-making to fully tackle energy efficiency. So these drives and motors are what we call connected assets that allow real-time monitoring when they are connected to software, and as well as doing predictive maintenance instead of preventive maintenance. In ABB Motion, we are able to implement an energy appraisal and has the right solution for constant monitoring. This is what we call ABB ability. So as I mentioned, the motors and drives, we connect them to what we call the software. For the motors, we have this smart sensor. It is not only being connected to ABB motors, but it is also open to other brands that are rib caged. And it acts like an Apple Watch that you can simply monitor your motor, even though your technical personnel is not on site. And we also have this Neta 21. Neta 21 that can be connected to the drives to do the monitoring and to be connected to the portal. So it enables to take actions that lead to less downtime, of course, extend the lifetime of the equipment, lower cost, as mentioned earlier, reduce energy consumption, and of course, increase the profitability of the customers. So it offers also full transparency of key operational parameters to individual assets as one unified system. So moving forward, this is only a data insight for better decisions making. So ABB audited last year around 2,000 motors in the span of June to September. And during this time, we were able to achieve 31% of energy achievement potential, which is over 2 terawatt hours of energy saving. Imagine it is enough to power around 1.250 household per year. So this is just an example from UAE, Germany, and US. This is the CO2 savings tons we were able to save, and also the ROI is between 3 to 6 months, and others is 12 to 2 years. So ABB has partnered with CERN. ABB and CERN was able to identify 17.4% energy efficiency saving in terms of cooling and ventilations motor. So during this joint research, we have identified that energy saving potential is equivalent to more than 18,000 European households via the ABB energy efficiency audit. So CRN will use the data to selectively upgrade motors, as what I've mentioned, the synchronous reluctance motors, the IE5 efficiency, with highest energy saving potential with projected payback for only less than 2 years. So if achieved, this savings could be enough to power more than 18,000 European households and could avoid 4 kilotons of CO2 emissions, and the same time as it's like planting over 420,000 trees. So the potential saving is around 17.4 across a fleet of 800 motors. One pump motor at CRN had an energy saving potential of 64%. So here in the Philippines, we also did a project wherein we had the replacement of low efficiency motor at Dole, Philippines, and we have achieved an actual savings. Actually, the end user was able to achieve 60% of savings just on replacing the IE1 motors to IE5 motors. So imagine having those savings to run also and help operational costs of the customers. So with that, just to have a key takeaway, energy efficiency is a key pillar for achieving low carbon society. And electric motors and drives hold the key for sustainable industries. And the journey towards energy efficiency should be data driven. So I just want to say this, that what you can't manage is the data that you can manage is the data you can measure. So it's always important to measure for us to be able to manage the data we need. So I would just like to invite everyone that ABB is just a founding member of the energy efficiency movement. It's a forum that promotes the use of energy efficient solutions and technologies to save energy, reduce costs, draw down CO2 emissions. So here are the links that you can follow, and everyone is invited and free to join. Thank you so much.
Absolutely fascinating, and putting the spotlight on electric motors, completely fascinating. Thank you so much, April. Now we come to our final speaker, Dr. Luis Gonzalez. Luis is an industrial digital expert with 25 years of experience in AI, data science, and digital transformation in the power industry. At Aboitiz Data Innovation, ADI, and Aboitiz Power, he leads initiatives to enhance operational efficiency, revenue generation, and ESG. Luis heads the AI Center of Excellence and collaborates on data science and applied engineering projects within the Aboitiz Group. As a co-founder of the AI Asia Pacific Institute and a guest lecturer at Nanyang Technical University, he champions ethical AI deployment. Previously, Luis held significant roles at Element AI Asia, co-founded with Joshua Bangoy, and GE Power Digital. He has a background in computer science along with postgraduate diplomas from MIT. So, Luis, over to you, please.
Thank you very much, and thank you for the invitation to speak. I'm going to talk to you today, and I'm kind of glad that I'm talking at the end, not to you as an engineer that understands data science, but as a data scientist that has seen what we're doing with climate change in our power industries. And I'll do a quick declaration. It's not working. We're not doing good enough. Everything that we did, I was running GE Digital for 4 years. Everything that we're doing, it's not working. It's not working enough. It's good. It's not good enough. Now, let me explain why. I'm going to give you my arguments as to why I think it's not good enough. All right. So the privilege of working in the Philippines is that you get to see all the impacts of climate change in real life. And you get to see them in a way that you have no choice but to take them on. Why? Because you need to still develop the country. I call it the impossible problem. How do we sustain our economies? How do we get people out of poverty? How do we reduce the price of kilowatt hour while dealing with climate change impact? It's an impossible problem. Now, I work in the power industry for the last 28 years because the hypothesis when I graduated from school was that software will change the way we run energy in the world. And this is where part of my hypothesis, it's not good enough. We need to do more. What do we need to do more? Yes, we can make our systems more efficient, for sure. And it will have an impact. Look at that 73%. But it's not through interventions that are driven by business cases on return on investment that we will do that. You see, most of the stuff that my colleagues and I have concentrated on is coming up with production efficiencies, energy efficiencies, material efficiencies, productivity availability, or demand efficiencies as well, right? As a form of reduction. But the main driver of those use cases, and I know because I fight with this in my company every day, is return on investment. Sure, if it's CO2 involvement, if there's compliance on CO2, it's beneficial. But the main driver is not to actually improve climate change. That's a nice byproduct behind it. And the problem with that, in my view, is that it's just not going to create the impact we're looking for. And look, I'm Canadian. I moved to Asia because of the Yichu line, right? If you put a North Thailand line of 3,000 miles and circle it around, half of the world lives there. We could change whatever we want in North America, in Europe. It's not going to make a difference. We need to do it here, where people live, with Indonesia, where India, where China, where Philippines are growing, and they have that impossible problem. How do we how do we become a developed nation without damaging the planet? And that's actually, today, is not something we solve for. We first deal after the economic growth, and then we worry about climate change, just like the Americans, just like the Canadians, just like the Europeans did. So how do we should be thinking about the problem? This is my hypothesis. Everything we hear around climate change in AI talks about intervention. Use cases for each business, facilitated by OEMs, by consultancies, facilitated by experts, on intervening the improvement of efficiencies, the reduction of emissions. One thing we don't do, and we're not going to do by our own, I declare right now that Aboitiz Power is not going to monitor itself, nor any independent power producer in Asia, is monitoring, risk scoring, impact to an actual planet. Like my colleague from Black and Beach really adequately said, this is not a linear problem. We don't emit more CO2 and all of a sudden damage the planet. It's a huge, complex systems problem. So therefore, our monitoring cannot be linear. We cannot monitor power plants and say, how many CO2 tons did you emit last year, and expect to actually have an impact on climate change? Yes, it is an intervention, and yes, it's a good intervention. It's just not good enough. So when we talk about monitoring, what can AI do? And now it's when I'm talking to you as a data scientist. Welcome to AI for Climate Change 101. Yes, we can monitor emissions, and this is a model that we have. If you're interested about NOx, SOx, and CO2 monitoring in power plants or cement plants, yes, we can do that. And it's helpful to do that, of course. It's an intervention. But what I'm talking about is how do you monitor the impacts of climate change on Earth? Impacts that matter to you. That's Project Salvation. What Project Salvation does, it takes images of satellites and it looks at landslide risk profiling to start. Why do we care about that? Well, in our case, because we have hydroelectric generation and we want to prevent silting. But that's also citizen protection. And when you have enough information of satellite imagery on a particular area of the planet, what else can you get? You can get emission leaks protection. Do you know that actually hydroelectric produces a lot of methane when the turbine is spinning on the water? And methane is a lot worse than CO2. And this is why I think it's not good enough how we set it up, because we're not looking at the true impact to the planet. We're only looking at, the hypothetical impact within a plant or within an operation. The other thing is we need to be doing more forest fire risk scoring. We need to do more crop yield risk scoring, water resources risk scoring. And one thing we haven't included into our monitoring is climate refugee monitoring. How people are being displaced by these impacts. Now, should individual power producers do this? So OEM will do this? No. This is where I come to my part of the presentation. This is what can ADB do. How many of you have used ChatGPT before? Raise your hands, please. All right, close to it. You know what GPT stands for? It's a pre-trained transformer. What does a pre-trained transformer do? Is decoding all the languages of the planet, started with the English language, and encoding it for the purpose of use continuously. What I'm proposing to you is Gen AI in this space of climate change can encode and decode our planet impact. We put images, we create clusters of those images, we annotate them for the impacts that I just talked about, and effectively help us monitor the true impact of the planet. And then you go back here and you measure from that monitoring the true impacts of those interventions. And that's how you build regulation. And no, this is not something that should be kept to any particular company. It should start like OpenAI, which at the time was open source. And it should be regulated by a global agency of climate change. Not by GE, not by Siemens, not by Schneider, not by ABB. Sorry. Hope you guys like that. AI 101 for the climate. Thank you.
Fascinating. I think here we have really opened up and learned from a different perspective how we can approach the climate crisis and how we can drive energy efficiency and achieve our climate goals. But I wanted to, and here I'm having an open discussion with with our speakers and the audience. And I first wanted to ask, what is the uptake of these solutions across industries, and what are the barriers to really increase and accelerate the uptake of such digital and artificial intelligence solutions, and how can we drive it to achieve those improvements? Over to you. It's open to all of you.
No, I figured. I think maybe both of us can take this along with OEMs. I think it's very piecemeal right now, and it is very piecemeal. It's very siloed, and it's very not only technology but also very specific to industry verticals. As rightly pointed out, we need to look a lot beyond and a lot more high level to be able to integrate all of that. And when we start looking at like planetary solutions of digitalization, this is where AI should actually play a role, rather than necessarily, for those of you who are into Bitcoin, generating digital currencies and things like that, which is where a lot of this is going. So yeah, a systems approach looking at all the complexities across the planet, and then feeding into regulation, informed regulation, that then goes back and de-risks the financials to be able to invest and make informed decisions.
Yeah, I would even add to that. I think that's a great point. And when you provide visibility to not just how we generate, let's say, for example, kilowatt hours, but how we buy the fuel and how we trade that energy, it helps banks to restructure the loans that are one of the main reasons why we don't shut down coal. So if you have a way to provide more visibility and make better decisions, it actually helps change the system so that we can move toward different sources of electricity. Right now, the problem is the only sustainable from an economic standpoint perspective of maintaining the lights on are still hydrocarbon centric.
I think to add on to that, the wider outtakes of these smart or digital solution in the industry, I think to tack on to what you just said, as long as the ROI makes sense, industry will deploy them. When the ROI become 8 years, 10 years, then that's become challenging. Nobody would deploy such a technology because it doesn't make sense. And let's say from a policy perspective, how can government really then advocate it? To me, I think there's two things. Number one is, does the people know what are the solutions out there? Do they have the capability and awareness? So that's where government policy can come in and set in place. And digitization, talk about cybersecurity, right? If from a country or policy setting, if they can have a standardized cybersecurity rules or standards, the company then can adopt, then it can expedite, the in-country industry to deploy such solutions.
Thank you very much. I think you have already raised a few points I want to explore a little bit more. One is, of course, how international organizations like ADB and UNIDO can drive the uptake. You have heard from Peter that his facility is now offering support for such pilot projects, and I really hope that we will get, and his facility can get some exciting proposals in that area as well. And ADB has had support to digital solutions, but have we done really well? Or what should we do better? Then, of course, Pei-Sung, you have raised policy and also cybersecurity, and I want to discuss that as well. But maybe first we can look at how ADB and UNIDO and other international organizations should step up, and what should we do differently?
I have a question. We're measuring GDP, right, as sort of a key performance of economic activity and improvement and maturity of countries and people. If we're measuring that by consumption, that's a problem. I think we need to look past that, right, into a measurement by the UNFCCC, by UNIDO, by ADB, by World Bank, by AIB, by all the climate funds to come in and support the planet, literally, and all of the EU, etc., to look seriously at how do we measure progress? What do we quantify? And it's not GDP. I think GDP is an outdated tool. So it might need to move to a sustainable GDP calculation that triggers that performance standard, right, of success. And that needs to be underpinned by investment. And how do you calculate that across economies? How do you calculate the green or the sustainable attributes? Then that go into the financing and the regulation, right? So looking at ADB and looking at the likes of MDBs, that's maybe where the focus needs to be driven. Because then everything trickles into that, or it trickles down into all of the rest of the industry and education and everything else that goes with it.
And maybe just to add, I mean, particularly with official development assistance and ODA funded to developing countries, it's very much looking through the SDGs as a framework for looking at impact. So beyond just GDP growth, but the 17 Sustainable Development goals as a really good indicator. So just to expand, I think some of the roles of multilaterals. I mean, we mentioned briefly about these types of programs to help to de-risk through grant funding some of the investments that might be higher capital cost initially to do through pilots, but also the role of World Bank, ADB, IFC to come in with those concessional loans to get those first projects going, so then they can become commercial at scale in those countries where they might not yet be commercial. So a lot of these technologies, when we look at one country, they might already be commercial, but in another country, the same technology might be at an earlier commercial readiness level or technology readiness level. So we need to look at the context. One thing we're actually doing at the moment in UNIDO is a large-scale market assessment on smart energy and digitalization across ODA countries, across all three regions, Asia Pacific, Africa, and Latin America. We should have the results of that at the end of the summer. So very much we will share that. That's things like the landscape of innovations in smart energy applied not just to industry, but to clean energy using sectors, landscape of technologies, innovators, countries, where's the most demand, where's the enabling environment for policy and regulation. So hopefully that will be quite a useful piece of work.
Are you using AI for that?
I can let my colleague Yi Zhang answer that question.
If I could add one last thing. If we consider money and the fact that it really has no value at all, but just the value we provide to it, or gold, right? The idea of providing value to ecology, measuring that value and punishing the depletion of it financially, not just by governments, but by lending organizations, that to me makes a lot of sense. We just published a paper on blue economy, and I think tracking through satellite imagery, water and ecology depletion, and that costing you extra risk dollars when you're doing insurance, when you're doing loans, that will drive, because the world moves towards what has economic value, even if it's perceived value, right? So let's then create this perceived value, which it's argumentable it's not that perceived, of our actual planet, of our ecology, and then build it into the systems that we use for lending and running operations of energy, for example.
Well, fascinating thoughts. Yeah, natural capital accounting and alternative measurements for economic and sustainable economic growth is a big topic, is also a big topic in ADB. We have established a natural capital lab cooperation with the university in San Francisco, Berkeley Natural Capital Lab. And when we talk MDB evolution, we really look at how we can support better sustainable financing, i.e. also better financing condition for a sustainability loan. Recently, I had the opportunity with an industrial talk to an industrial leader, and a key challenge is still that financing conditions are not reflective of the sustainability of their investments. So, and data-driven decisions here are also, as you say, extremely important. So that we have discussed this, so maybe we can move over to the policy environment in Asia and the Pacific to really drive data-driven energy efficiency. And what are your experience in across the region? I think Yatin, you're also working across the region. What do governments still need to do to really step up there?
So I live in Singapore. I think that's exactly. And I don't think you can take maybe Singapore, Japan, and Korea and China as examples, because they have a very different context to a lot of the developing world. I think India is also kind of progressing down, looking at how to use data in informed decision making. But I think it's learnings and maybe looking at how we can apply data-driven decisions based on the proliferation of the kind of data that we're collecting across different geographies. I'm not that aware, unfortunately, of how much data is actually being used in regulatory reform outside of these few countries, which might need some intervention with respect to knowledge exchange. So I think there's still a ways to go. Mind you, it's pretty new overall in terms of having AI-driven analytics and things like that over the past few years. But there has to be some transfer of knowledge and a scale-up of capabilities in all of these geographies for people. With the educational system, there's a gap there, both on the regulator side as well as the people who are actually able to have the skills to operate.
I think from the energy efficiency side, regulatory play a very important role. In Singapore, they started the Energy Conservation Act. They mandate people to monitor and put in plan to reduce their carbon footprint. I think similarly, Philippines in the last 2 or 3 years also implemented similar policy. So that, if implemented across the region, could have a small impact. Efficiency is not great. It will not give you 40, 50%, right? But every tons count. So that's one. So in terms of, let's say, digitizations, policy do play a part. For example, in Singapore, they started these smart nations policy a couple of years back to then advocates bring up the awareness, do the competency training for the people. So those are good story potentially then can be replicated across the region, but then it depends on the drive and determination of each country governments to deploy them.
I would just like to add to what Baisong mentioned in terms of Philippines. Yeah, we do have this RA 11285, the energy efficiency law in the Philippines. It has already been in place, but I think the major problem here is the financial stability of not only the user but also the end user. I think it is viable to come up with innovative financial solutions like, revenue sharing agreements. I think that works more viable, especially to those end user who would like to do energy efficiency, but at the end of the day, they don't have that budget to do the things that they have to do. Technology is everywhere, but money is still the problem.
One last thing. We, as part of the Institute's work, we advise APEC on AI policy. And when it comes to sustainability, I think the concept of data-driven policy is really important. Most of the policymakers in Southeast Asia copy things that are done elsewhere, and that's entirely wrong. What you should do is put regulatory sandboxes, allow for a project, invite multiple participants, and from the results of that project and that pilot, write your policy. Policymakers need to understand what data tells them about policy and become data-driven policymakers. Otherwise, you won't be able to do it with AI.
Okay. Thank you. Now I want to address maybe the elephant in the room, which is cybersecurity. And this region is not necessarily known for or is known for high cybersecurity risks. And how do as a solution provider, how do you help industry who want to embark on this journey but are concerned about cybersecurity? How can you help them to address this risk?
A bit of solution selling. So from Schneider Electric perspective, we actually has a very good cybersecurity consulting team that is very, very an expert in the OT layer. So on the IT layers, you have the big IT companies managing them, but OT layer, that's where we come in. So if any company has challenges, because once you go digitizations, right, everything at the OT level would somehow or rather make itself way out to the IT layer. We do provide the consulting services to support you on your journeys.
Actually, not to help him on his speech, but we are doing the first fully on the cloud power plant in the Philippines, actually in Southeast Asia with Schneider and Aviva. They work, it's good. Perhaps one of the things I could add is cybersecurity leaders in Southeast Asia are really getting stuck in the past. They still think of building a wall that no one will transfer. With AI, especially with generative AI coming in, they will cross that wall. So you've got to forget about how high your wall is. You got to figure out how to fastly react, like a immune system kind of reaction for every single threat that you have, which means you need to get very good at understanding how to create discriminators to help those generators of AI threats. This topic of generators and discriminators comes from adversarial networks. We're trying to do education, to be very frank, but it's really early stages. We're about 5 years behind to where we should be to be able to protect our critical infrastructure. So not to depress you guys, but we're really behind. And in that sense, we gotta build a lot more education and start thinking of how do we protect our critical assets in a very different way. Yeah.
5 years behind, that's a bit scary. I would like to now open up the floor to the audience and encourage you to pose your question. Yes, we have a microphone over there. If you could please also share your name and where you come from. Thank you.
Hi, my name's Richard. I work for WWF, based in Cambodia, working also a lot in Vietnam and other countries. I've been to a lot of, I guess, light industrial factories, and there's a great need for kind of simple software on measurement, but also on kind of IoT for processes. But what I find is that everything on the market is too expensive, and it's not getting into the hands of companies. At the same time, I used to work at UNEP, and we had a UNEP UNIDO program developing some industrial ecology software, and that is sitting in a stack of CDs in Nairobi and never used and never maintained. And if you give it to the public sector, it's also not great. So I'm just wondering, do you see any opportunities to bridge that? Okay, we have these very overly expensive solutions that factories don't have, but at the same time a willingness for the public sector support. But I find I've not yet seen a good solution that the factory is willing to pay for, basically. And is there a way we can bridge that divide? I think particularly for Luis, I thought you were gonna come to that.
Well, there is definitely that realism, right? That we're not running in North America where there's millions of dollars for anything we want to try. In my view, one of the advantages, and it happened to us at Aboitiz in combination with Schneider and Aviva, is that we were so behind that why go through the entire process of on-prem IoT and all these learnings that takes decades? Let's just go directly to cloud. I was running Windows XP in my power plant. Okay, please, there's no one from Aboitiz, right? Shit, I'll get in trouble for that. And I had to say, like, there's no way, we got to go to the latest. We can leapfrog. I think if you take an operation in Cambodia, for example, with the help of ADB's funding, and get them to say, become a poster child for jumping to the latest on one investment go, and perhaps some financing to allow them to get to that reality, they can leapfrog, right? Not go through the learnings of Europe, North America, but try to go to the latest possible or closest to the latest possible to pay all your technical debt. And then redefine your business in a way that it will survive, because that plant in that factory, 5 years from now, probably won't be around. The ties will have completely obliterated that industry. So if you set it up in that way, I think that you can give a chance, a new lease on life on a brand new business paradigm, right? But for me, the secret to drive this is a combination, like an ecosystem combination between technology, financing, and business leaders, to be fair, which could very well in Cambodia mean the government, right?
My takes in terms of funding is you don't have to put in the whole platinum-plated solutions for your customer, right? Put in small, quick wins. You don't have to be the whole solutions, part of the solution, to showcase to them that it adds value, and use the value that's generated from that deployments to invest on other use cases. Step by step. Digitization is not a 2-day journey or 2 months journey. You switch it on, your whole plan is digitized. It is a 2, 3, even 5 years journey. Start small, get the use cases, get everybody on board, use the savings to invest on the other use cases.
Yeah. I think on the...
Then you add in the standardized use cases, standardized deployments, straightforward.
And
we can work with you.
Finally, I think one of the really important steps that we haven't looked at is the startups. You got to have new small companies that are not predated by established conglomerates to be able to deliver this. And I work for one of those, but in a way that's true. Like innovation is really stagnated when you have 5 companies control the country, right?
Thank you for sharing your experience, your wisdom, and your passion. It's contagious. We started with the theme of advanced technologies for decarbonization and so on. A couple of days back, ADB colleague showed a project in China of leasing for MSMEs in China. and how a tracker like a smartwatch was attached to each of the equipment that was leased because they could not afford to purchase the equipment, what you mentioned from Philippines, for example. And you mentioned two interesting stakeholder groups. So I'm curious, any policymakers in the room? And finance companies? So the policymakers, they have to report on those SDG indicators. They also have to report as per this UNFCCC template on how emissions and carbon is being reduced in those hard to abate sectors. All of the companies in those sectors in each country gets a template in which they should report manually data. It should all get combined together. And then somebody has to do this verification. Wouldn't all this decarbonization, monitoring, online thing, cybersecurity support them to reduce the effort they take collecting?
Absolutely.
And second part, the finance folks always says time is money, time is money. Who wants to go and check every single company who they had given money to and say, oh, what happened last year? Wouldn't it be useful if that data is available to all those people? If a company said, I have a certification for energy efficiency and ISO 14000 and so on, why wouldn't they want to showcase the energy efficiency improvements per day? Is that something that comes up? Thanks.
One of the reasons I'm a big believer in monitoring is because it creates at least a constant measurement of where we're trending towards. And you can monitor emissions, you can monitor impacts quite openly. And if we did it so in an open source form, meaning with the entire planet able to eventually do that, just like we've decoded languages on Earth, which in 10 years from now, ChatGPT will have every language that humans speak. We could do that for our planet in the impacts that we have. Now, in that sense, monitoring is the closed loop where you make the loop now intelligent. Your interventions are helping in this way. So instead of just giving compliance targets, you can do more intelligent decisions as to how do you contribute to the problem. In my view, this should be something that banks should want to do because they want to measure risk. That's how they lend money and insurance. And this, at the end, if it was available, it'll make it easier for everyone to track for their own real purposes. I think the problem is we don't even have an agreement on how are we actually going to track climate change impacts, which is where I don't think one company can do it. That was my comment behind no OEMs, no private companies can do that. I think that's something that we need to agree on a different level, right? Maybe as nations.
Going to your questions about the data that goes directly to the regulator to do reportings and all that, I think that's a good approach, great ideas, right? All regulators would want to do that. So, they save out on their resources. But the challenge is usually not at the regulator level. It is the company. A lot of times they do not want to share this data directly to the regulator. And that's the biggest challenge. It's not about whether they want to do it. It's a lot of time the company do not want to share this data so easily. I used to work for some of the big oil and gas in the regions, trying to get one piece of data science God knows go through how many reviews. So I think the challenge is not we don't have the technology. We have the technology. Your power consumption at home is transmitted. Why can't we do that for industry? Is because the industry end user do not want that data to be shared so easily.
If no more questions from the one, please go ahead.
Hello, I'm Hugo from Alcom Carbon Markets. We produce biochar here in the Philippines, and we're looking to digitize our MRV process. And I was especially engaged by Luis' presentation about AI and the environment, and especially the crop yield risk factors. I don't know if you have some research already done on that, and which specific parameters will you monitor? And also, once you monitor these parameters, also with soil degradation and everything, how can you monetize this increased data that you have in order to justify this cost?
So we can have a longer conversation because I need about 3 hours to answer that in detail. But we have salvation is being demoed this month. We built it for our purpose of landslides, but the signal richness of satellite imagery, especially once you include heat waves and some of the other signals that are non-visible to the eye, you get a lot of potentials, right? Crop yield prediction comes back from vegetation prediction. We do that for the purpose of lines, but yeah, you can chart vegetation behavior and erosion in a very accurate way, close to about an 80th percentile. And then we use generative AI to guess the points of pixels that are not there, right? As a closer neighbor, if you think. So we actually get close to the 90th percentile just by having the right intent on what we're trying to annotate. And as long as you have a good expert on agriculture, for example, or agrotech expert, and a geomorphic capturing, you could measure consistently and you'll get good answers. So how does that get monetized is something that my research lab hasn't really concerned yet with. We just want to monitor what's going on. And then I think there's a lot of potential for how companies use this in their own individual sectors. Mm-hmm.
And this kind of satellite monitoring, which is pretty accurate, like, will that need like another sensors to be deployed on the ground?
Yes, so we do, you have to do it the first time around to be able to correlate what you're finding, and then you do it periodically, maybe once a year. As you gain certain confidence on the measures, you need less and less on the ground measurements. My recommendation would be monitoring could be done satellite level. Interventions may include drone flying and then the specific areas where you want to intervene, right? So it's not meant to be, this is the exact point where the problem is, but it's meant to give you a good scoring area of, this quadrant of 1 kilometer is where we have the biggest problem.
Okay. Thank you very much. I'm looking forward to talk more about this later. Thank you.
Okay, thank you. At this stage, I would like to invite Yi-Jung to deliver some summary and of the session and the points discussed. Yi-Jung is, sorry.
I will introduce myself instead. I'm the coordinator, project coordinator, Smart Energy and Industry Decarbonization. In the A2D facility, Accelerate to Dumbchat. Peter just introduced that during his scene setting for the program, we provide fundings for supporting innovators on different thematic areas for clean energy innovation in UNIDO. And I'm very honored to be here to give the closing remark for this last session of the fourth thematic track. And I feel the people who are staying still in this room are both intelligent and patient, because we are solving the hardest problem of climate change, which is hard to abate sectors, industry, and also with most controversial AI technologies. And because we're just talking about solutions, and which is, I reflect myself, it's advanced digital solutions, and we put solutions before digital, because we are looking for how we giving solutions to problems instead of just trying to emphasize how we do with current available digital technologies. And the discussion of all the panelists is very interesting on how complicated this problem is. And also for the industry decarbonization side, no matter from the raw material selection, also to process optimization. And like a lot of panelists just mentioned about energy efficiency, monitoring on this science, it's a very complex process, and also needs a lot of patience to bring different knowledge, skills, and resources together, and also needs a very also patient cross-sector partnership. Just in this Southeast Asia region, we had a lot of also panelists mentioned about the current barriers, no matter regulations or financing, and you have capital there, you have investment there, but not matching with the correct technology or correct beneficiaries, and also with the available, like also a lot of passionate people in this room, and I talked in the formal sessions about the problems we are facing. I think ADB provided a good platform for us to making a chance for people to connect, no matter you are innovator looking for funds, and us is a good example for the A2D facility. We are providing grants, and then also for the people who are just those panelists, Yating, who mentioned about the data centers and the heavy-duty vehicles working on, and Pensong mentioned about the project models, especially digital twins, with contribution for the energy efficiency, and also EPRA mentioned about how do we connect unconnected assets with models to make better performance, and also Luis mentioned our risks and how we do through monitoring, which is now we can see sparks in the room and how they can start from small step and then accumulating into years, bring values and attract attention from the government and also bankers to say how we can really work together to solve the problems. It's hard, but still possible. So and then I would try to mention our facility again because we are going to have our founding core this summer. And please do apply, especially in this room for smart energy and industry decarbonization. There's two thematic areas. And also, if you can see from the screen, there's a feedback form for the session. If you want to have raise any other questions we didn't have enough time to raise, please scan the QR code and submit to us. And then I will hand it back to Peter for final closing.
I'll be really quick because I think we literally have actually we have -4 minutes, so I'll just do this in 15 seconds. Just to say, I'm not closing this session in particular, but just to say, as a whole, the thematic track, for those that came to all 4 sessions, has been really exciting, has taken very much a thematic approach to how do we decarbonize industry. So we started with hydrogen on Tuesday, followed that with the role of renewable energy and energy efficiency. And then this morning, in the first session, we looked at the role of carbon capture, usage and storage. And now we've been looking at the role of digital solutions. So it's fantastic that we've had, for the first time ever at the Asia Clean Energy Forum, a whole thematic track dedicated to how do we decarbonize heavy industries. Hopefully next year, we can also get a thematic track as well to really get this conversation going. And I think one of the most interesting parts of across all 4 sessions was particularly the financing element of the different types of financing mechanisms that we might need to address this very challenging set of sectors, and how it's very context dependent. And there is a plethora of funding out there, but it depends on how it's been accessed and the way across how that varies as well between countries and companies. And the second most important thing was the number of interesting case studies that I think we've heard, both from countries that have shown leadership, whether it's at the policy level or whether it's through the way they're setting up the enabling environment, and also from companies that are really leading the way as well in this region with specific technologies and approaches. So just very lastly, I want to thank also the Asian Development Bank for putting on another great Asia Clean Energy Forum and a fantastic thematic track on hard-to-abate sectors. Thank you.
Thank you, Peter, and thank you for UNIDO's great collaboration on this track. So thank you, everyone, and I hope to see you in the closing plenary. And we have an afternoon of many interesting additional spotlight sessions. So please continue your ASEF journey. Bye-bye.